Hello and welcome to the continuation of Le Chatelier's lesson from Friday. So I wanted to go over this slide because it's actually really important, and I went over it relatively quickly. So I'm going to go over this again, and I'm going to say something pretty explicit or pretty directly. I kind of want you to write it down. So I said in class that temperature is the only thing that affects K. The other changes that we talked about previously in this lesson, okay, they affect Q, okay? But changes in temperature affect K. Okay, so the question is, how is K affected? Okay, well, in an endothermic reaction, you need to remember that an endothermic reaction absorbs heat. Okay, so if you increase the temperature, okay, you want to do something to decrease the temperature, right? And if you run an endothermic reaction in the forward direction, right, it's going to absorb the heat that you just gave it. And if you increase the reaction in the forward direction, that shifts towards the products. And the products are in the numerator of K, so that makes K increase. Again, the reverse is also true, that if you decrease the temperature, that decreases K in an endothermic reaction. Okay, this is, the reasoning here is complicated and they never ask you to explain it. So it may be worth memorizing that if you have an endothermic reaction and you increase the temperature, you increase K. Now, for exothermic reactions, remember, exothermic reactions release heat. Okay, so if you increase the temperature, you don't want the exothermic reaction to occur. Okay, so you're going to do the reaction in the reverse direction, right? And then you're going to make more reactants. Remember, reactants are in the bottom of the K expression. Okay, so then you're going to decrease K. So if you, in an exothermic reaction, if you increase the temperature, that decreases K. Now, this is the slide that I said you guys are taking too long to write. Okay, whoa, too fast. So again, if the stress is decreasing temperature, the relief, okay, of this would be increasing the temperature. And as a result, we're going to shift towards the direction in which the reaction is exothermic, or towards the heat. Okay? If you increase the temperature, okay, the relief that you need is you need to decrease the temperature, and you're going to shift towards the endothermic reaction, because remember, endothermic reactions absorb heat, or you're going to shift away from the heat. Okay, so if you remember, we did the first one, so I'm going to skip that one. But here, and I need my pen because I need to write. So, pointer options, pen. So here we have an endothermic reaction. The reason why I know this is an endothermic reaction, okay, is that the delta H is positive. Endothermic reactions absorb heat. And when you absorb heat, heat is a reactant. So I'm going to add H here to stand for heat. I'm writing with the mouse, so I'm not going to write heat. You can write the word heat here. All right, so that is where the heat is. So now the question is, which way will the reaction above shift if the temperature is decreased? Okay, well, if the temperature is decreased, that means we want to add heat to the reaction. Okay, well, which way will add heat to the reaction? If we go that way, we're shifting towards the heat. Right? And actually, this reaction going forward is endothermic, but going reverse is exothermic, and that's going to release heat into the environment, okay? Which will then bring the temperature back up. Okay. Now, the purpose of Le Chatelier's principle, or what Le Chatelier's principle is used to do, is you can force a reaction to go in the direction you want it to go, right? So sometimes the K, let's say for example, let's say the K for this reaction was less than 1. So that means it stays towards the reactants, okay? But you want to make a lot of the products. So you can use Le Chatelier's principle to shift reactions in particular directions. And so the question says, name 3 ways, okay, that what we can do to make this reaction shift towards the formation of the product or shift to the right. Well, the first thing that we talked about was changing the concentration of the reactants or products. So we could shift this reaction to the right or towards the products if we add more, and we always want to add gases. So if we add more of the reactants, so if we add, and you can actually do it with the solid too. So if you add more of the reactants, okay, that will shift this direction, okay, to the right, right? Because you're adding more, let's say you're adding more SO2, and you should be writing this down. So 1, you could add more SO2 to the reaction, and that's going to make, since you want to use up that SO2 that you just added, that's going to shift the reaction towards the products. Okay? The other thing you can do, which is kind of silly, because if you want to make more of it, why would you take it away? Okay? But if you want to shift the reaction towards the products, as you're making O2, you can remove it, okay, from the reaction, or from the, like, whatever, the flask, whatever it's occurring. And if you remove O2, right, remember, Le Chatelier says you want to, relieve the stress that you're causing by removing the O2. So the reaction is also going to shift to the right if you remove O2 from the mixture. Okay. We also talked about what you can do in terms of pressure and volume. Okay. So if we look, remember, that has to do with number of gas particles. So if we look at this side, there are 2 gas particles on the in the reactants and 3 gas particles on the product. So what could we do, okay, to shift the reaction towards the products? Well, we have more pressure on this side, right, because we have more gas particles. So if we put this in a larger container, like we put this reaction in a larger container when it's at equilibrium, okay, so when we put it, what's that going to do to the pressure? Well, if we put it in a larger container, okay, that's going to decrease the pressure, okay, and because volume and pressure are inversely proportional, so if you make the volume larger, you decrease the pressure, and then the reaction is going to shift in the direction that's going to cause more pressure, and that is in this direction, or where there's more gas particles, which is the products. Okay. The last thing we talked about in terms of how to shift a reaction is in terms of heat, okay, or in terms of changing the temperature. This reaction has a negative delta H, so it's exothermic, so that means heat is a product. Okay. So the question now is, what can we do, okay, to shift the reaction, okay, towards the products? Okay. Well, heat is a product, and we want to shift the reaction towards the products. So if we lower the temperature, okay, the reaction will be forced to shift towards the way that generates heat, and that's in the forward direction, or towards the products. Okay. Now, if you have not written a list of those 4 things, or 3 things, I guess there's 4 of them, you should go back and re-listen to this, and rewrite the 4 things that you could do to force the reaction in this direction, or to force the reaction in the product direction. Doing with concentration, doing with volume of the container, and doing with temperature. You need to go back and look at those things, write them down in a list form if you haven't. Okay, this chart we are going to go over Tuesday in class, so I'm not going to have you fill this out now. We have 2 more effects that we need to talk about, which are rarely discussed on the AP exam, but I want to put them. Sorry, I pressed the stop button. So they rarely talk about these on the AP exam, but I wanted to just bring them up. So an inert gas, first of all, you should write, an inert gas is a gas that does not react. It doesn't like, a lot of times the inert gases are considered to be the noble gases, which are in group 18. So the question is, if you add this like random inert gas, okay, to the reaction mixture that isn't in the reaction, like it's not taking place in the reaction, it's like a random gas, okay, what is that going to do to the equilibrium? Okay, well, first of all, inert gases only have this effect when the reaction is at constant pressure. Okay, so the reaction has to be at constant pressure, or they have to say that in the reaction. And if you add an inert gas at constant pressure, then the total volume will increase. Okay. As a result, okay, that will cause the partial pressure of the reactants and products to decrease. Okay. So if you change the partial pressure, okay, of the reactants and products, okay, that is going to cause the equilibrium to shift towards the direction in which there are more moles of gas. Okay, so in general, you don't really need to know this whole like explanation because they never ask for it on the AP exam. It just tends to be in the multiple choice. If you add an inert gas, which again is a gas that doesn't react, or a gas in group 18, okay, it shifts the equilibrium towards the direction where there are more gas particles, because that's going to increase the partial pressure of the reaction. Okay, they never ask for you to describe that. So if we look at this, okay, we're adding an inert gas, okay, to this reaction, okay, at constant pressure, okay, and it says where will the reaction shift? Well, remember, we just said if you add an inert gas, it decreases the pressure of the reactants and products. So you're going to shift the reaction towards the direction that increases the pressure. Okay? And if you again, that has to do with the number of moles of gas. So that's going to shift this reaction to the right. Okay? And the reason is that because an inert gas decreases the pressure of the reactants and products. So you want to increase the pressure. And the pressure will increase when you move it to the right. because there are more moles of gas as products than there are as reactants. Okay. So, the last thing that we need to talk about, and this is easy, is the effect of a catalyst. Okay? A catalyst, in case you don't know, is something that speeds up a reaction. Okay, we're going to talk about this much more in not the next unit, but the following unit. Catalysts speed up both the forward and reverse reaction. So if you add in a catalyst to a reaction at equilibrium, it just makes both reactions occur faster and has no effect on the overall equilibrium. So a lot of times in a multiple choice, they're like, which of the following will shift the reaction forward? Okay, or in the left, to the right. And one of the choices will be a catalyst. That is never the correct answer, because catalysts have no effect on equilibrium. Okay, so for homework, you have to finish that packet that it talks about Le Chatelier, and also do the questions on the lab, but you'll get an email. Have a good weekend.